Okay, this is the introduction for the lab on rotational dynamics, or torques cause angular accelerations. And what we're essentially going to do is we're going to set up the rotary motion sensors with a disk, just like we did in the previous lab. And rather than have a mass on each side of this, we're just going to put a mass on one side and say, wow, look at this. This torque on this pulley causes an angular acceleration of this disk. If I increase this mass, I increase the torque, and I increase the angular acceleration of this disk. Not exactly rocket science here. So here's what we need. We need a computer with Logger Pro. The masses are going to be paper clips and roughly 16-gram nuts. We need the same aluminum disc set that we had before. We need the rotary motion sensor, ring stand, some string, not a body length, but maybe half a body length or so, as well as a metal rod. I'm going to show you this in just a second, but I want to get to step number 2 here first. You're going to connect the rotary motion sensor. You all know how to do that. You're going to tape some string to the inside edge of the pulley. The reason why I have you do this is because if you just let this thing wind down, then it's going to keep on ripping the string off the pulley and it's going to be a pain in the butt. So please tape the string in there and you will save yourself lots of heartache. And you're going to record the radius of the pulley. You're going to stick with the largest step of this 3-stage pulley. So let's take a look at what we're dealing with here. Here we have the rotary motion sensor and the pulley. You're going to measure the radius of this pulley using the calipers that we used last time. Again, make sure you take the battery out when you're done, please. We're going to have the same aluminum disc set that we had before. And just like we did with the Atwood's Machine Revenge Lab, what you're going to do is you're going to open up this box. There's probably going to be this plastic bag with 4 discs inside of it. This disc right here, put it back in the box. This giant washer, I guess, right here, put that back, or don't put it into the box, put it back into the bag. You want to pick one of these 2 guys, it really doesn't matter to me which one, and put the remaining one back in the bag. Please put them back in the bag, because otherwise they kind of jar around and bad things kind of happen. The masses that we're going to be using are these nuts that are roughly 16 grams each. We need some paper clips to hang these nuts from the string right here with, and we also need this rod. Now when you go ahead and you tape this string right here to the inside of this pulley, I would use some of this teeny tiny tape that's up front, and you're just going to put a little teeny tiny piece of tape right there. That will make your life so much easier. Then what you're going to do is you're going to put the aluminum disc on there, wind this thing up, and you're going to hang a nut from this thing. Let's pop back to the Word document, and here we can kind of see that we're going to set this thing up and it's going to let this thing hang freely. You are going to measure the mass and the radius of that aluminum disc just like you did for the Atwood's Machine Lab, and you're going to record these guys in the data table kind of right here and right here. You're going to start data collection and you're going to let that thing kind of wind down, and we're going to record the angular acceleration of the disk. If I were you, what I would do is I would look at the angular velocity versus time and say, you know what, I know that the slope of angular velocity versus time is angular acceleration, and I'm going to look for when this thing is in free fall, and you're going to record that guy just right over here. When it comes to the torque, what you're going to do is you're going to record the hanging mass. You can technically do this later if you're in a time crunch, but you can use Newton's second law to determine what the torque is. Then what you're going to do is you're going to go ahead and increase the mass by 1 nut, and you're going to record the hanging mass, you're going to record the angular acceleration, you're going to record the torque. Increase it again, record, increase it again, record, and so on and so forth. Show me one sample calculation of your torque and just go ahead and fill this data table out. Again, you can do this after the fact, so if I were you, I would hold off on doing this until I was sure I had all my data. Then what you're going to do is you're going to record the mass and length of the aluminum rod. That is the aluminum rod that I showed you just right over here. And you're going to go ahead and attach that from onto the rotary motion sensor using the center hole. It's probably going to look kind of like this. You're going to wind this thing up and you're going to let this thing kind of unspool, and you're going to more or less repeat the process. You're going to use a hanging mass of 1 nut, 2 nuts, 3 nuts, 4 nuts, 5 nuts, and you're going to fit a linear fit to the angular velocity versus time, get the angular acceleration, and so on and so forth. Then what you're going to do is you're going to fill out the torque column just like you did before, and then you're going to say, well, here's what I know about torques and angular acceleration. I know that for this particular lab I'm going to have one torque, and that's going to be equal to the rotational mass multiplied by the angular acceleration. If I were to do a curve fit to this, and if I were to plot torque on the y-axis, and if I were to plot rotation or angular acceleration on the x-axis, if I were to fit this to y is equal to mx plus b, then I don't know about you, but this guy right here is going to look a whole awful lot like that guy right there. So the slope of this line is going to be equal to the rotational mass. So I guess you do need to calculate your torque values before you leave. You're going to go ahead and put the torque on the y-axis in log of pro. You're going to go ahead and put the angular acceleration on the x-axis in log of pro. And then you're going to say, hey, log of pro, go ahead and fit a linear fit to this, and you're going to record its value. You're going to say, well, here's what I know for a disk. I know that the rotational mass is going to be 1/2 mass radius squared. And I'm going to say this is my theoretical. Let me go ahead and compare my experimental to my theoretical. My experimental was just my slope. Then what you're going to do is you're going to do the same thing for the rod. You're going to look what that guy up, or look up what that guy is. You're going to fit a linear curve to it, and you're going to compare the theoretical to the experimental. Last but not least, we have one tiny little extension to do, and you can do that on your own time.